Hello everyone, welcome to our channel RecentJobs. If you are preparing for an SQL interview, especially as a fresher, then you have come to the right place. In this video, we are going to dive into the most important SQL concepts that are essential for any interview. This concept will not only help you ace your interviews but also gives you a strong foundation in SQL. In this video, we will be covering important concepts like types of SQL commands, constant, aggregate functions, clauses, joins, views, subqueries, and normalization. Let's get started with the first concept, types of SQL commands. SQL commands are divided into different categories based on their functionalities, allowing us to perform various operations on the database. Let's explore these categories in detail. Data query language or DQL commands. As the name suggests, data query language commands are used to query and retrieve data from the database. The primary command under DQL is select, which helps us to fetch data based on the specific criteria. Coming to data manipulation language or DML commands, data manipulation language commands allow us to manipulate the data within the database. Commands like insert, update, and delete fall under this category, enabling us to add, change, or remove data. Coming to third command, data definition language or are used to define and manage the structure of the database. These commands such as create, alter, and drop help in defining and changing the schema or database objects. Coming to data control language or DCL commands, data control language commands are essential for managing access control within the database. Commands like grant and revoke allow us to control who can access or change the data and ensuring data security. Coming to transaction control language or TCL commands, finally transaction control language commands come into play during a transaction. For example, when withdrawing money from an ATM or making an online payment, all the commands involved in managing a transaction in a database come under TCL commands. So the very first command is data query language command, that is DQL command. DQL is used to retrieve the data from the database. So any command which is helping us to fetch the data from the database or retrieve the data from the database, that comes into the DQL command. Here you can see command which is uses select. So consider that I want to get details or I want to fetch the details of a student who is in class 2 whose roll number is 3. So what I will do? I will make a database query in which I will use the select command, and in that I can fetch of all the details about a student who is in class 2 and having the rule number 3. So this select command would help me to fetch the data or to get the data from the database. The second type of SQL command is data manipulation language or DML commands. These commands are used to manage and change the data in a database. They help us to perform tasks like adding, updating, or deleting data. Let's use a college database as an example. Insert. When a new student joins the college, we need to add their details to the database. To do this, we use the insert command. Coming to update, if that student moves from semester 1 to semester 2, we need to update their record in the database. The update command is used to make this change. Coming to delete, when the student graduated, we may want to remove their information from the database. The delete command is used to delete their record. The third type of SQL command is data definition language or DDL command. These commands are used to define and manage the structure of the database itself. They help us to create, change, and delete database objects like tables and indexes. Let's understand in brief. Create. When you want to set up a new table or database object, you use create command. For example, if you are creating a table for storing student records, you would use create table. Coming to alter, if you need to make changes to an existing database object, the alter command comes into play. For instance, if you want to add a new column to the student table, you would use alter table. Drop. When you need to remove a database object such as a table or view, you use the drop command. For example, drop table will delete an entire table and its data. Coming to truncate, if you need to quickly remove all the data from a table but keep the table structure intact, you use the truncate command. It's faster than delete and it's often used when you want to empty a table but not delete it. The fourth type of SQL command is data control language or DCL commands. DCL commands manage who can access or change data in the database. The main DCL commands are grant and revoke. Let's discuss in brief. Grant. This command gives users permission to access certain data. For example, a teacher might be granted access to see student records. Coming to revoke, this command removes permission from users. For example, if a teacher no longer needs access to student records, their permission can be revoked. In our college database example, grant. If a teacher needs to view student information, we use grant to give them this permission. Coming to revoke, if a student access to their record needs to be changed, we use revoke to adjust their permission. The final type of SQL command is Transactional Control Language or TCL command. TCL commands help manage transaction in a database. The main TCL commands are commit, rollback, and save point. Coming to commit, it saves all changes made during a transaction. For example, if you are transferring money and everything is correct, commit finalizes the transaction. Coming to rollback, cancels all changes made during a transaction if something goes wrong. For instance, if there is an error, rollback will undo the transaction. Save point. Mark a point in a transaction so you can go back to it if needed. Why TCL commands are important? Imagine you are doing an online transaction like paying for something. If you complete the payment but the transaction isn't processed properly, TCS commands ensure that any issues can be corrected. For example, if the money is deducted but the payment isn't completed, rollback can undo the deduction and the money will be credited back to your account. TCL commands help ensure the transactions are handled correctly and consistently. Select command. Select is a data query language or DQL command. It is used to retrieve data from a database. Retrieving specific columns. When you want to retrieve specific column from a table, you use the select command and list the columns you are interested in. Syntax to retrieve specific column. Select column 1, column 2 from table name. Retrieving all columns. If you want to retrieve all columns from a table, you use wildcard character, that is asterisk, which represent all columns. Syntax to retrieve all columns is select star from table name. Let's discuss update command. The update command is used to change or modify existing records in a database table. Basic syntax. Update table name. It specifies the table where the update will occur. Set column name equals to value. It defines the column to be updated and a new value. Where condition. It specifies which row should be updated based on the condition. Let's understand with an example. To update the salary of all employees in the HR department to 60,000. Update employee indicates the employee table being updated. Set salary equals to 60,000. Set the salary column to 60,000. Where department equals to HR. It updates only those rows where the department is HR. Let's discuss delete command. Delete command in SQL is used to remove one or more records from a table based on a specified condition. The basic syntax of the delete command is delete from table name. Specifies the table from which records will be removed. Where condition. It defines which rows should be deleted. Only rows that match this condition will be removed. Let's understand with an example. To delete the record of an employee with the name Raj, query. Delete from employee. It indicates that records will be deleted from the employee table where name equals to Raj. It specifies that only the rows where the name column matches Raj should be deleted. Let's discuss alter command. Alter is a DDL command that is used to change existing database objects such as table, indexes or constants, basically doing some modification to the schema. So whenever we want to make any kind of changes to our database object, we use the alter command. For example, consider an employee database. Currently, this table has 3 columns. Now there comes a requirement where I need to add one more column to this employee table. This addition of a column is done using the alter command. Similarly, if there is a requirement to change the column name from employee ID to ID, this change is also done using the alter command. So whenever we want to make any kind of changes to our database, we use the alter command. Let's see all the things that the alter command can help us to do. It is mostly used to change the schema. So whenever we want to make changes to columns like adding a new column, deleting a column, modifying a column and much more, we use the alter command. Let's understand with example use cases. Let's see how the alter command is used with queries. Adding a column. As I mentioned, the alter command helps us to make changes to the schema. So whenever we want to add a column, basically doing some changes to the schema, we use alter command. Let's understand the query. The query for adding a column is alter table followed by the table name. Then we provide add followed by the column name we are adding, the data type of that particular column and constraint if it is necessary. Whenever we are adding a column, we provide all properties like the column name, data type and constraint. We provide this alter command followed by the table name in which we want to enter the data. Drop a column. Let's understand with this query. Start with alter table followed by table name. Use the drop column command. Finally, specify the name of the column you want to delete. This command will remove the specified column from the table. To modify the data type of an existing column in a table, you use alter command with the modify class. This allows you to change the properties or definition of a column. Let's discuss the query and how it works. Start with alter table followed by the table name where you want to make the change. Next, use the modify command, then specify the column name you want to change and then provide the new data type for that column. This command will update the specified column with the new data type. Change the name of existing column. If you want to change the name of a column, example, from old name to new column name and optionally update its data type, you would use alter command. Let's discuss the query and how it works. Start with alter table followed by table name and then use the change clause and provide old column name and the new column name. Optionally specify the new data type if you also want to change it. This command will change the old column name to the new column name and update the data. Another way to rename a column, table, index or constraint is by using rename command. This command allows you to change the name of various database objects. You can use the rename command to rename a table, column, index or constraint in your database. Let's understand with query and how it works. Start with alter table followed by table name and use rename clause and then specify what you want rename. Example, column name or table name. Provide the old name followed by 2 and then a new name. So what is exactly the truncate command? Simply, truncate is a data definition language command used to remove all records from a table in a quick and efficient manner. But unlike the delete command which removes record one by one, truncate wipes out all the data at once, resetting the table back to its original empty state. Let's consider an example. Suppose you have a table called employee and you want to clear out all the data to start fresh. The truncate command makes this super easy. So what is drop command? Drop command is a data definition language command used to completely remove an entire database object. This can include tables, index, views or even entire database. When you use the drop command, the object is permanently deleted along with all its data and this action cannot be undone. Let's go through an example. Suppose you have a table called employee that you no longer need and you want to remove it from your database, then we will use drop command. Let's understand the query. Drop table name. Another way to rename a column, table, index or constraint is by using rename command. This command allows you to change the name of various database objects. You can use the rename command to rename a table, column, index or constraint in your database. Let's understand with query and how it works. Start with alter table followed by table name and use rename clause and then specify what you want rename. Example, column name or table name. Provide the old name followed by 2 and then a new name. Let's discuss DCL commands. Grant. This command is used to grant permission on database object from one user to another user. Let's have a look at query. Permission type. This specifies what the user is allowed to do, like select for reading data, insert for adding new data and many more. On object name. This tells which database object like table or view the permission apply to. To username. This is the user or role who will receive the permission. Revoke command. This command is used to cancel given permission. Let's discuss the syntax. Revoke permission list on table name from user list. Let's discuss TCL commands. Commit. This command is used to present saving of data in the database. Let's understand the syntax. Commit. Once you execute commit, all changes made during the transaction are permanently saved to the database, and this is used to ensure that all changes are applied and cannot be undone. Rollback command. This command is used to get data or restore the data to the last committed state. Rollback undoes all changes made during the transaction effectively and restoring the database to its state before the transaction began. It is used to cancel changes if something goes wrong. Syntax. Rollback. Coming to save point, it creates a point within a transaction that you can roll back to without affecting the entire transaction. And it allows you to set a marker within a transaction. You can then roll back to the save point if needed, which undoes changes made after the save point while preserving changes made before it. And syntax save point and save point name. Let's discuss constants and its types. Constants defines rules or conditions that must be satisfied by the data in the table. Let's understand different types of constraint. Unique constraint. It ensures values in a column are unique across the table. Let's understand with an example. If you have a column for email address in a table, using a unique constraint, make sure no two rows have the same email address. Coming to not null constraint, it ensures a column cannot have a null value. Example, if you have a column for username and you apply a not null constraint, it means every user must have a username. Coming to check constraint, it enforces a condition to be true for each row. Example, if you have a column for age and you apply a check constraint that age must be 18 or above, the database will only entries where the age is 18 or more. Coming to default constraint, it provides a default value for a column if no value is specified. Example, if you have a column for country and set a default value USA, whenever a new row is added without specifying the country, USA will be automatically added. Coming to primary key, this does not allow duplicate and null values. Example, if you have a user ID column as a primary key, every user must have a unique ID and no two users can share the same ID. Example, roll number. Coming to foreign key, it enforces a link between two tables by referencing a column in table that is a primary key in another table. Example, if you have a user ID column as a primary key, every user must have a unique ID and no two users can share the same ID. Let's discuss aggregate functions. Aggregate functions perform some operations on a set of rows and then returns a single value summarizing the data. These are used with select statements to perform calculations. Let's discuss some of aggregate functions: count, sum, average, min, and max. Let's consider an employee table that has several columns, including ID and salary. Imagine we have data for 3 employees already stored in this table. Now, if we want to perform any kind of manipulation or retrieve specific values from the data, we can use aggregate functions. These functions allow us to calculate various metrics across a set of rows. Examples of aggregate functions: maximum salary. Suppose you want to find the highest salary among all employees. You can use the max function to do this. Coming to minimum salary, if you need to know the lowest salary of an employee is getting, you can use the minimum function. And to find out the average salary paid to employees, you can use average function. And then if you want to know the total salary expense for all employees, the sum function is what you need. And if you find out how many employees are in the company, you can use the count function. Let's discuss one by one aggregate functions. Count function. It counts the number of rows in a table or number of not null values in a column. This counts how many things are in a list or a group. Let's understand the syntax. Select count of name from employee. So this defines the number of employee in a company. Coming to sum, it calculates the sum of all values in a numeric column. Syntax: select sum of salary from employee, and this defines the total amount of company is paying to its employee. Coming to average function, it computes the average of all values in a numeric column. It finds the average or middle number of all numbers in a list. Syntax: select average of salary from the employee. So it returns average salary of an employee working in a company. Coming to minimum function, it helps to find the smallest number in a list. Syntax: select minimum of salary from employee. Max: it finds the maximum value in a column. Syntax: select max of salary from employee. What are clauses in SQL? Basically, clauses are conditions or tools that help us to make queries more specific and decide what data we want to fetch. So here we have mentioned all types of clauses which are there in SQL. So the very first one is where clause, which is used to filter out the data. And the second clause is group by clause, and third clause is having clause, and fourth clause is order by clause. Fifth and final clause is limit clause. Let's discuss the syntax. Select column 1, column 2 from table name and clause condition. Let's discuss where clause. Where clause is used to filter rows based on specified conditions. It allows you to retrieve only the rows that meet certain criteria. Let's understand the query. Select column 1, column 2 from table name where condition. For example, consider you want to get the details of employee whose age is greater than 20. You would use where clause to apply this filter. The SQL query for this would be select star. It retrieves all columns from the table, and from employee, it specifies the table from which we to retrieve the data. And where age greater than 20, it filters the rows to include only those where the age is greater than 20. This query will return details of employees with ages greater than 20, that is aged 25, 26 and so on. Now the second clause is limit clause. The limit clause in SQL is used to restrict the number of rows written by a query. Let's understand with an example where you have a school with several students who scored above 90. Suppose there are 5 such students, but you only want to view the details of the top 3. So we will write a query. Select star from students where score greater than 90, order by score, desk limit 3. This query will first sort the student based on their scores in descending order and then return only the top 3 students. Let's discuss how the limit clause works. When you use limit clause, you specify a number n which determines how many rows you want to retrieve. So for that syntax, select column 1, column 2 from table name, limit n. N indicates number of rows. Example with all columns. Select star from employee, limit 2. This query will return the first 2 rows from the employee table regardless of how many rows are actually in the table. Let's discuss order by clause. Order by clause in SQL is used to sort the result written by a query in either ascending or descending order. This is particularly useful when you want to organize your data based on specific criteria, such as sorting employees by the salaries from highest to lowest. Consider you have an employee table and you want to retrieve the details of all employees, but you want the result sorted by salary from highest to lowest. Then order by clause is used. By default, if you don't specify the order, the result will be sorted in ascending order, that is smallest to largest. If you want to see the salaries from highest to lowest, you can explicitly specify descending order. The basic syntax of order by clause is as follows. Select column 1, column 2 from table name, order by column name, ascending or descending order. Example, select star from employee, order by salary, desk. This will give the employee details sorted by salary in descending order, that is highest to lowest salary. Let's discuss group by clause. Group by clause is used to group rows that have the same values in specified column into summary rows. This is often used with aggregate functions to perform calculations on each group. Let's understand basic syntax. Select column 1, aggregate function of column 2 from table name, group by column 1. Let's understand with an example. Let's say you want to group employees by the department and calculate average salary for each department. Then you would use group by clause along with aggregate functions like average. Here is how you would write the query. Select department, average of salary as average salary. This selects the department and calculates average salary, and as average salary gives a name to the calculated column for better readability. From employee, this part defines the table from which to retrieve the data. Group by department. It groups the rows by the department column. This means all the rows with the same department will be aggregated together. This query will return a result with each department and average salary of employees in that department. For example, if you have departments like marketing and sales, it will show the average salary for each of these departments. Having clause. The having clause is just like where clause, but the main difference is it works on aggregate data. The having clause is typically used with group by clause to apply condition to a grouped data. For example, if you are grouping employees by department and calculating the average salary for each department, we might only want to see those departments where the average salary is above a certain threshold. Let's understand how it works. Select the columns you want to display, then use aggregate functions like average, sum, or count on the relevant column from the table you are querying. Group by. It defines the columns you want to group the data by. Having clause. A condition that filters the group data based on aggregate functions. Let's understand with an example. Select department average of salary from employee, group by department having average of salary greater than 1500. In this query, we are selecting the department and the average salary for each department. Then we are grouping the data by department. The having clause then filters these groups to only include departments where the average salary is greater than 1500. This way, you ensure that only the departments meeting the specified conditions are included in the final result. Let's discuss next important concept in interviews, that is joins. Joins in SQL, as the name suggests, join. So basically we are joining something to get a desired result. So joins are used to combine rows from two or more tables based on related, shared or common column between them. So whenever we have two or more tables that have a related or a common column between them, like consider an example of ID. The ID column is present in the student table, course table as well. So that particular ID column is shared or common column between all those tables. We can just join them and get all the related details we want from all these two tables. There are commonly four types of joins used in SQL: inner join, outer join, left join and right join. Now in these particular tables, you can see there is a student table and then there is a course table. In the student table we have ID column and in course table we also have an ID column. Since they both have a common or shared or related column, we can perform join operation on them to get the details of name, age, course ID and course name for a particular student. Let's discuss different types of joins in SQL. Inner join. An inner join helps us in getting the rows that have matching values in both tables according to the given condition. So whenever we want the values that match in both tables, we use inner join. Now here you can see that there are two tables, customer and order table. There is one column that is common between both tables, that is ID. So we need to find the values that are present in both customer and order tables. Let's see. If 101 is present in the order table, no, it's not. So this value is discarded. Then let's take ID 102. Is 102 present in the order table? Yes. So this value would be written in our final result. Then it will check for 103. Is there any value with 103 existing in the order table? Yes. So we will return 103 as well. The query for this looks like select column from customer, inner join order on customer.id equals to order.id. This query will return all the values that match between both tables. Now let's dive deeper into the query. Table 1 and table 2 here represent customer is the first table and order is the second table. So we can reverse the order of these tables in an inner join and it won't affect the result. This is because inner join focuses on getting the values that are common between both tables. However, when dealing with other types of join, the order in which you fetch the data can impact the result. Example, the query returns the rows where there is a matching ID in both tables. Select star from customer, inner join order on customer.id equals to order.id. So in this query, we select all the columns from both tables, that is customer table and order table, and we perform inner join on the ID column, which is the common column in both tables. The result will include only the rows where the ID is common between the both tables. Next type of join is left join or left outer join. It is used to fetch all the records from the left table along with the matched records from the right table. Consider that we have two tables, table 1 and table 2, where table 1 is left table and table 2 is right table. In the left outer join, we get all the details from the left table along with the values that are common between table 1 and table 2. So the left outer join retrieves all the records from the left table along with the matched records from the right table. If there are no matching records in the right table, then null values are written for the columns of the right table. Let's discuss how the query is structured. Select. We specify the columns we want to display in the final result. Left join. We specify the second table, which is the right table. Next, on. We provide the condition on which the join is based, that is the common column between the two tables. The table specified before the left join keyword is called left table, that is table 1, and the table specified after the left join keyword is called right table, that is table 2. We must maintain the order because we want to retrieve all the details from the left table. Example, let's look at the practical example with two tables, customer, that is left table, and order is right table. In the left outer join, all the values from the left table, that is customer, will be retrieved along with the common values between the customer and order tables. The query first retrieves all the values from the customer table, that is 101, 102 and 103, and then it finds the common values between these two tables. Let's check. Is ID 101 present in the order table? No. So the order table column for ID 101 will have null values. Coming to ID 102, it is present in order table? Yes. So the values 102 and laptop from the order table will be included in the result. Then is ID 103 present in the order table? Yes. So the values 103 and mobile from the order table will be included in the result. For ID 101, since there is no matching entry in the order table, so null values will be filled in for all columns of the order table in the result set. In summary, a left outer join ensures that all records from the left table are written with matching records from the right table where available. If no match is found, then right table column will contain null values. Now we will discuss third type of join, that is right join. The right join or right outer join is used to fetch all the records from the right table along with matched records that are present in both left and right tables. If there are no matching records in the left table, so null values will be written for the columns of the left table. Let's look at the query structure. We start with select and provide the columns we want to see in our result. Then we specify from and provide the first table, that is table 1. Next we specify the type of join we are performing, which in this case is a right join. Finally we give the name of the second table, that is table 2, and provide the condition on which the join is based, that is table 1 dot column name equals to table 2 dot column name. In this context, the left table is the one specified before the right join keyword, then right table is the one specified after the right join keyword. So in our example, table 2 is the right table and table 1 is the left table. Now let's understand how this right join works with an example. Consider two tables, customer, that is left table, and order is right table. In a right outer join, we will get all the details in the order table, that is right table, along with the matched values between the customer and order tables. It will retrieve all the values from the order table such as ID 102, ID 103 and ID 104 along with the corresponding values like laptop, mobile and TV. Now it will find the common values between these two tables. Let's check. Is ID 102 present in the customer table? Yes. So it will return the details for ID 102. Coming to ID 103, is ID 103 present? Yes. So it will return the details for the ID 103. Is ID 104 present? No. So it will return null for the columns from the customer table. This way, the right join ensures that all records from the right table are included with nulls for any unmatched records in the left table. We have learned about left join as well as right join. Now what happens in full join? Let's first revisit the concept of left and right joins. In a left join, we retrieve all the details from the left table along with the common records between the left and right tables. Coming to right join, as the name suggests, we retrieve all the details from the right table along with the common records between the left and right tables. Now what is full join? A full join returns all the matching rows from the both left and right tables and also includes all rows from both tables even if there are no matching rows. Essentially, a full join is a combination of both left join and right join. Simply we can say that full join is a combination of left join and right join. Coming to MySQL, the full join keyword is not directly supported. So instead we can achieve the same result by using a combination of left join, right join and the union keyword. The union combines the result of the two joins and eliminates any duplicates. Let's understand the query. Query for the left join, use the union keyword and combine it with the right join and write the query for right join. Let's understand with an example. Select star from customer, left join orders on customer.id equals to orders.id and then use the union keyword to combine it the right join. Then write the query for the right join, that is select star from customers, right join orders on customer.id equals to orders.id. This combined query will give as result of a full join. Finally, when you execute this query, you will see all the details from both the left and right tables along with the common records between them. Next important concept is views. In SQL, a view is a virtual table based on the result set of an SQL statement, and it helps in providing a filtered view of data for security purpose. Let's discuss how to create a view in SQL. Creating a view is a straightforward method and syntax is as follows. Create view name as. This is where you define the name of your view. Select column 1, column 2. Here you select the columns you want to include in your views. From table name, this part defines which tables your data is coming from. And coming to where condition, finally you add any conditions to filter the data. Let's discuss how to view data in the view. Once you have created your view, you can see all the data in it with a simple query. That is select star from view name. This will show you all the columns and rows that match the criteria you set in your view. Let's discuss how to drop a view in SQL. If you ever need to delete a view, you can do so with the following query. Drop view if exists view name. This command removes the view from the database. Finally, we can say that views are powerful tools in SQL that help you manage and secure your data more effectively. By creating views, you can limit access to sensitive data, simplify complex queries, and make your database operations more efficient. Next important concept is subqueries in SQL. SQL subquery is a query nested within another SQL statement. Whenever we want to retrieve data based on the result of another query, we use nested query. Imagine you have two queries Q1 and Q2. Q1 is the main query and Q2 defines the subquery inside Q1. The subquery Q2 gives some result, say R2, and the main query Q1 then uses this result to do further operation. This is useful when you want to get updated data without having to manually change your queries every time something in your data changes. Why should we use subqueries in SQL? Subqueries are useful because they allow you to perform complex operations in a single query. They help you get dynamic results that update automatically as your data changes without needing to manually adjust your queries. Subqueries can be used in different parts of a SQL query. Let's understand in brief. In the select clause, you can use a subquery to calculate a value that will be used in main query result. Let's understand with an example. Suppose you want to show all employees along with the average salary in the database. Here, select average of salary from employee is the subquery that calculates the average salary. And then this average is then shown next to each employee's name. Coming to where clause, a subquery can be used to filter records based on the result of the subquery. Example, if you want to find employees who earn more than average salary, in this case, the subquery select average of salary from employee calculates average salary. Then main query then selects only those employees whose salary is above the average. Coming to from clause, subqueries can also be used in from clause to create a temporary table of a result. Example, if you want to see the average salary for each department and only show departments where average salary is above 1000. Here the subquery is select department of average salary as average salary from employee group by department. It creates a temporary table with average salaries for each department. The outer query then filters this table to only include departments with an average salary greater than 1000. Next important concept, normalization in SQL. Normalization in SQL is a process used to organize a database into tables and columns. The main objective is to reduce redundancy and ensure data integrity, meaning that data is stored effectively and consistently without unnecessary duplication. Normal forms. Normalization is typically done in stages called normal forms. The most commonly used normal forms are first normal form. It ensures that each column contains atomic values and each entry in a column is one of the same data type. Coming to second normal form, it achieves first normal form and ensures that each non-key column is fully dependent on the primary key. Let's discuss third normal form. It achieves second normal form and ensures that no non-key column depends on another non-key column. If you found this video helpful, don't forget to like, share and subscribe for more content. Thanks for watching and good luck with your interview preparation. See you in the next video.